Hello explorers and welcome back to another day of Advent of Code, and we are going to do day 5 today. And if you haven't seen day 2, I recommend you go back and watch that before you watch this one, because in day 2 we implemented an int computer. And this int computer, we're gonna continue build on this today. And there were some environmental system called test terminal, environment supervision terminal. And it had a diagnostic program, and we're going to run it through our int computer. But our computer has a few more commands now. First off, we have 2 more opcodes, 3 and 4. 3 is to take an input, and 4 is to take print outputs. So if we get a 3, then it will take 1 parameter, and that parameter will be the input to send. And if it's where the input should be put, and number 4 will give an output, so the next parameter will be printed. Then they have also added modes, and there are 3 different modes. So on the opcode you have 02, for instance, and each 0 can be omitted. So if there is just 1, then it's not interesting. So, and that's because one of the opcodes was 99. But if we have, for instance, 02, so that's 1 operation. And then you have modes in positions. So the first variable C, which is the 100 position, that's actually looking for the first parameter and which kind of mode it is. Is it intermediate mode, so we'll take that number which stands there, or is it position mode, so we'll actually look into the array for that value. And then you have the same for the B value, which is in the 1000 position, and that's the second parameter, and in the 10,000 position you have the third parameter. So the computer is getting a little bit more complex, but it should be interesting to write this up. There are a few very simple programs here, and I'm gonna see if we can figure this one out. So I'm gonna start some coding, and I'll be back when I actually have done some work. And we are back. So now I have written some code. I have run the examples that were provided to me. And the last thing I should do was running the program with the provided input of 1. And I'm a little bit... it should output a lot of zeros if everything is okay. But then I get an array out of bounds exception here for a large value. So I wonder if this is the correct value. We'll try that out. It was! Nice! So I get a gold star, you get a gold star, everybody gets a gold star. So let's look at the code and look at the changes I made. I was really sure that I had done something wrong. So first off, I have the program up here that we have added. Then we have the input of 1. And we have a little break before the program, so we can break the program. Could have used system out as well, but I wanted to print something in the end if I actually went through. And then I will do a for loop for the program until length, and I will not supply the actual increment because that will change at this time. And then we'll get the first opcode here, so that's the opcode of the program, so the program opcode. And then we have these modes for the different parameters. I've set parameter 1 mode, and this is actually the value of the 100th place in the series. So I will do a modulus operation on 1000 first to remove most of the data, and then I will divide by 100, and that will give me the first mode, P1, and then I do the same for the thousands, so I get P2, and then I will divide by 10,000 to get P3 mode. And the opcode, the actual program code that I was looking for, so from 0 to 99, that I will do a modulus operation of 100. So that will give me the first 2 bits. So if we look here, so this will give me this bit here. This over here will get that one. And the last one will get the 10,000th position. And the one below here will just give me the last 2 digits. So this is these 2. If you have 5 numbers. So maybe this opcode should be in the beginning here. So that's how I get all these modes out. Then I have 2 values that I start at 0. And if the program length is longer than the program pointer plus 1, so I can actually get this value, I will check if the mode is intermediate, then I will just get the value of the program at that position. Otherwise, I will get the value of the memory address that is put on that position, so somewhere else in the program. And the same goes for when we have lower than opcode 3, so opcodes that have 4 parameters or 3 parameters. So, and then I will see that I can actually get the second parameter, and that's the value here. Having a P3 mode, so the actual program counter is intermediate, then we will not store anything anywhere. Or do we? Wait a minute here. We might do that. We will store something on the position that we are standing at the moment. Yeah, so let's put in an else statement here. It was funny that it actually worked like that, but just in order to make this complete, because this is how we store the value of the result. So either we store it on the parameter 3 or position, or we store it in the memory address pointed out. But I guess that this program will work either way in the same same way. So this is a little less useful, I believe, than the first one here. And then in both cases, both 1 and 2, we will push the program pointer +4. And then we have the case 3. So this is actually taking an input and taking an input. So maybe we should do a little bit nicer code here. So we can say private static final int addition. And that's 1. And then we have multiplication. That's 2. And then we have input and the output. So these are 3 and 4. And then we have exit program. So that's 99. So then we will be able to actually have this a little bit less confusing. Multiplication, and then we have input, the opcode input, and we have the output opcode and the exit program opcode. If we want to, we can actually do refactoring of this, rename opcode like that. How do we do this? What did it say? Rename shift 6. So opcode shift 6 opcode. So just clean this up a little bit. This is not important to solve the program, but it's important to make the program readable. So if we have an input and the first parameter has a 1, then we will just move the program counter on, because we will not take an input in this case, because we can't take an input to the program, or can we? I second guess myself now. We can actually put it into the position right there. Yeah. So this should also be valid as an input. And then we have, let's see, that's the correct one. Yeah. So if we are input 1, we will put it right on the variable position. Otherwise, we will look for the memory address and put it over there. And if it's output, we will just output value 1 that we prepared earlier, and we will move the program pointer up to, so the opcode and the parameter. And if it's an exit program, then we just break out. So let's run this again, and we will still get the same result here. So now we have solved the first one. Let's go on to the second part, and I will read this one and I will get back to you. And I'm back, and I've read the instructions here, and it's pretty simple. It's not that much more that we need to do. We need to add 4 more opcodes. We have one jump if true, jump if false, less than or equals. So jump if true will take the first parameter, and if it's non-zero, it will jump to the position of the second parameter. The opcode 6, jump if false, this will take the first parameter, even if it's 0, it sets the instruction pointer to the value of the second parameter. And then we have opcode 7, less than. If the first parameter is less than the second parameter, it stores 1 in the position given of the third parameter. Otherwise it stores 0, and then we have equals that does the same. So these operations are pretty simple to implement, I believe. The logic is simple, and I think we have the framework to handle this. Might be required to change some of the logic that I put in for this input-output kind of thing, where I didn't want to look at the second parameter. But it should not be that much work. So yeah, I will get on coding and I'll be right back. And we are back. So in the last example, we should run this program with the diagnostic code or the ID of 5, and then we will get a number, and this is the large number that we get over here. And the changes I've done to the program is that I have made a little bit of a check here. So if the opcode is exit program, then I don't need a first value, and if it's input, output, or exit program, then I don't want the second value for this program. So that's the simple change I made up there. Then we have down here at the jump if true. So if the value is larger than 0, I will just put the pointer to value 2. So I believe it should be not 0, so it could actually be a negative value, right? Let's see if it's the first parameter is non-zero. Okay, so it could be a negative value as well, and then we will set the pointer to that. But because we use both these values, so this is a 3 long instruction, so if we shouldn't jump, then we should jump over this instruction with the value 1 and 2 and this pointer. Same goes for false. We also need to jump here. And these else cases, I didn't do anything of that. So my program actually locked up the first time I ran it because I didn't have this pointer update when the value was not, or when the condition was not met. And then less than, also very simple. I will check if the P3 is 1, so it's intermediate. Then I will change. I will save it in different spots, and the only thing I check is if value 1 is less than value 2, then I give a 1 or a 0 if false. And equals is pretty much the same, but I use equal signs instead. and we need to jump up 4 program pointers here. So that's pretty much what I changed in the program. So, and I have tested this with all the examples that they have given. There were one example that checked if the value was 8 or not. There were one example that checked if the value was below 8, 8 or above 8, and you got different values then. So most of these programs have been very good to actually check that you are on the right track. So I really hope that this is the right answer. And it is! We got another gold star. You got a gold star. I got a gold star. Everybody gets a gold star. We have solved day 5. I hope that you found this video interesting. I hope that you learned something today. If you have any questions or comments, leave them down in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that, and I really hope to see you in the next video.